property of a quadrilateral. Okay, so what is angle sum property of a quadrilateral? That means in previous classes we have studied that angle sum property of a triangle. What is angle sum property of a triangle? The sum of angles of a triangle is equals to 180 degree, isn't it? So here in similar way we have angle sum property of a quadrilateral. Okay, now we all know each diagonal divides a quadrilateral into two triangles. Okay, now let us draw AC. Okay, so from first let us see ABCD is a quadrilateral and AC be a diagonal. Okay, AC as diagonal we have chosen here. Now because of AC, after drawing AC we got two triangles ADC and ABC. Okay, now let us take ADC. Okay, in ADC, so we are using here angle sum property of a triangle. Okay, angle ADAC plus angle ACD plus angle ADC. Okay, these are the angles. Okay, the sum of these angles is equals to how much? 180 degree. So here it is. Okay, let us call this as 1. Then similarly we have another triangle here ABC. Okay, in ABC, CAB this angle. Okay, and then ACB this angle and ABC this angle. Okay, the sum of these three angles is equals to again 180 degree according to angle sum property of a triangle. Okay, call this as 2. Now adding 1 and 2, what we get here? Adding 1 and 2, DAC plus ACD plus D, angle D is equals to 180. Okay, plus is equals to 180. So the same thing let us write here, adding, isn't it? DAC plus ACD plus D, angle D, plus CAB plus ACB plus B is equals to 180 plus 180. So 180 plus 180 is how much? 360. So now DAC plus CAB, let us combine this one. Why DAC and CAB we are combining? Since see here you can see here in the figure CAB plus DAC, these two, this will become common angle. Okay, so therefore let us write here, then plus ACD. For ACD plus ACB, okay, this C will become common and angle D plus angle B is equals to 360 degree. Now angle A plus angle B is C plus angle D plus angle B is equals to 360. That is the sum of angles of a quadrilateral is 360 degree. Okay, now let us see types of quadrilateral. Okay, now what are the types of quadrilateral? The types of quadrilaterals. What are the types of quadrilaterals here? So first one, this is trapezium. This is one of the type of a quadrilateral. Okay, it is a quadrilateral having one pair of opposite sides are parallel. You can see in the diagram ABCD is a quadrilateral. ABCD is a trapezium which has only one pair of opposite sides are parallel. Okay, and AD and BC are non-parallel sides. Okay, now so that means what is the trapezium? Trapezium is a type of a quadrilateral which has one pair of opposite sides parallel and another pair of opposite sides are non-parallel. Okay, now let us move to next type, kite. What is a kite? It has two pairs of adjacent sides. Adjacent sides means like this. This is what? Okay, adjacent. Two pairs of adjacent sides are equal. Okay, two pairs of adjacent sides are equal, this and this. That is AD equal to DC, AB equal to BC. Okay, now let us move to next, parallelogram. What is a parallelogram? A quadrilateral having two pairs of opposite sides. A quadrilateral having two pairs of opposite sides are equal and parallel. Okay, you can see this is a parallelogram. It has, we can see two pairs of opposite sides, that is PQ is parallel to SR and PS is parallel to RQ. Okay, that is PQ equal to SR and PQ is equals to and PQ parallel to SR. Now PS is equals to RQ and PS is parallel to QR. You can see here. Okay, this is nothing but parallelogram. You can see the properties also here. Now let us talk about parallelogram. Types of parallelograms. See children, here types of parallelograms I am telling, but we are learning quadrilaterals. Okay, see in quadrilateral, if different properties if we see, we can name them as different, we can give them different names like trapezium, like kite, okay, parallelogram, rectangle, all those things. See, parallelogram means opposite sides are equal and parallel. They are called parallelograms. See, parallelograms, we can say it is a quadrilateral. It is a quadrilateral and which has two pairs of parallel sides and equal sides. Two pairs of equal sides. Okay. Now, in parallelogram, we have different types. See, first of all, parallelogram is a quadrilateral. Okay. How it is different from quadrilateral? It is different from quadrilateral since opposite sides are parallel and equal. Okay. Now, in parallelograms, we have different types. Those are rectangle, square. Okay. And even one more is rhombus. Okay. Now, what is rectangle? Opposite sides are parallel. See, opposite sides are parallel. Not all that. Okay, opposite sides are parallel and equal also. Okay, opposite sides are parallel and equal. Okay, and the difference between parallelogram and the rectangle is, here in parallelogram, each angle measures different. That is not exactly right angle. But in rectangle, we have right angle. Each angle measures right angle. Or one of the angle. If one of the angle measures 90 degree, then that parallelogram is called rectangle. Okay. Now, MN is equals to RS. MN parallel to RS. Then SM is equals to RN. SM parallel to RN. Angle M is equals to angle N is equals to angle R is equals to angle S is equals to how much? Exactly 90 degree. Okay children. So this is rectangle. Now let us see rhombus. Okay. What is a rhombus? See, it is a parallelogram and if it has all sides equal and parallel. All sides are equal and parallel. That means D is equals to EF is equals to FG is equals to GD. Like this. Okay. And then parallel, DE parallel to GF and GD parallel to FE. Okay. Now, next is square. What is a square? It is a parallelogram and it has all sides equal and each angle measures 90 degree. Okay. But how it is different from rectangle? Rectangle, opposite sides are equal, but in square, all the sides are equal. In rectangle, each angle measures 90 degree. Same thing in square, each angle measures 90 degree. Okay, children? Next, in rhombus, all sides are equal and parallel. Okay, understood? But each angle measures different. Understood? So therefore, it is different from square and rectangle. Okay, now let us see. Now here AB is equals to BC is equals to CD is equals to DE. Square. Okay. AB parallel to CD and AD parallel to BC. Now all angles equal to 90 degree. That is angle A plus angle B. Angle A is equals to angle B is equals to angle C is equals to angle D equal to 90 degree. Okay. Now next is, hope you all understood types of quadrilaterals. Now let us move to properties of parallelogram theorem. See, you must understand very carefully, and this lesson is like full of theorems and concept based, and you have to understand very well. Okay. Now theorem: a diagonal of a parallelogram divides it into two congruent triangles. Okay. Now, see one more. That means we studied just now what is a parallelogram, and property also we studied. What is a parallelogram? Parallelogram has two opposite sides equal and parallel. Two opposite sides equal and parallel. Okay. And one more thing is a diagonal. What we draw, that one of the diagonal divides the parallelogram into two congruent triangles. What we get, the triangles, they are always congruent. Now let us see, let us prove that one. ABCD we all know, given you have to write, to prove you have to write, and then proof. Sometimes you have to write construction also. Okay, now let us see. Given ABCD is a parallelogram. How we have to write given? What is given here? See, a diagonal of a parallelogram divides it into two congruent triangles. That means parallelogram. Which is a parallelogram? ABCD is a parallelogram. AC is a diagonal. The diagonal AC divides parallelogram ABCD into two triangles, ABC and ADC. Okay, what we have to prove? We have to prove triangle ABC is congruent to triangle ADC. Okay, now proof. In triangle ABC and triangle CDA, let us compare both the triangles. Okay, now in this BC is parallel to AD and AC is a transversal. BC is parallel to AD, AC is transversal. Okay, so therefore we'll get alternate angles. Yes or no? What are the alternate angle? BCA is equals to DAC, this angle. Okay, now alternate angles, that is BCA is equals to DAC, alternate angles. Also one more pair of parallel sides we can see. AB parallel to DC. You can see here AB parallel to DC. And here also AC is transversal. Then which is alternate angles for this? Angle BAC is equals to angle ACD. These two angles. Okay, AC, BAC and DAC, alternate angles. Okay, now and AC is equals to AC, common. AC is equals to AC, common. Okay, this is common side. Now, so both the triangles are congruent by what rule? ASA rule. These two angles we compared and one side we compared. Our AC divides parallelogram ABCD into two congruent triangles ABC and CDA. Hope you all understood. Okay, children. Next. Example 1. Show that each angle of a rectangle is right angle. Each angle of a rectangle is right angle. So we have seen in the properties, we know that each angle of a rectangle is right angle. If we prove one of the angle is 90 degree, then we can say that the parallelogram is rectangle. Okay. Now let us see given. What is given? ABCD is a rectangle. Angle A is equals to 90 degree. Okay. Now to prove angle B is equals to angle C is equals to angle D is equals to 90 degree. Already angle is A is, we know that in the property, if one of the angle is equals to 90, then that is a rectangle. Already it is given rectangle. Okay, that means one of the angle is 90 degree. Now other angles also we have to prove. That is remaining angles are angle B, C and D. Now proof. Here in rectangle AD is parallel to BC and AD is parallel to BC. Then which is the transversal? AB is the transversal. Okay. Next. So we can write angle A plus angle B is equals to 180 degree. The sum of these two angles is equals to 180 degree. So how we got this one? What is the reason? Interior angles. Interior, these are the interior angles on the same side of the transversal. Okay, same side of the transversal. Okay, now, but we know that angle A is equals to 90 degree. Let us substitute in this. So, angle A plus angle B equal to 180 we know. Angle B is equals to 180 minus A. A is 90. So, angle B also we got 90 degree. Similarly, angle C is equals to angle A. Angle C is equals to angle A and angle D is equals to angle B. Why? Opposite angles of a parallelogram are equal. So therefore, angle C is equals to 90, angle D is equals to 90. Therefore, each angle of rectangle is right angle. This is the theorem and this is the proof. Okay. Now, let us move to the next example we have here. Okay. Next example. Show that the diagonals of a rhombus are perpendicular to each other. Diagonals of a rhombus are perpendicular to each other. So here rhombus we have drawn here. ABCD is a rhombus. We have in rhombus AB is equals to BC is equal to CD is equals to AD. All the sides are equal. Now let us compare two triangles here. Since we have drawn here diagonals, because of that we can compare here AOD. This is the triangle AOD and COD. These two triangles. Okay. So here AO is equals to OC. Why? Since diagonals of a parallelogram bisect each other. They bisect each other. That means it divides the diagonal into two equal parts. So therefore, then one more is OD. For these two triangles, OD is the common. Yes or no? OD is the common. Now next is two sides we compared. Now next is AD is equals to BC. AD is equal to CD. Why? All the sides are equal. Okay. And then therefore we can say the AOD is congruent to DOC. Okay. AOD is congruent DOC by what rule? SSS rule. Okay. Now angle AOD, this angle AOD is equals to angle COD. Angle COD, okay, is equals to 180 degree. The sum of the angles linear pair. Since it has linear pair. Therefore, both the angles are equal. Therefore, 2 times of AOD is equals to 180. AOD is equals to 90 degree. AOD is equals to how much? 90 degree. So, the diagonals of a rhombus are perpendicular to each other. See, this angle we measure 90 degree. Same here also 90 degree, 90 degree, 90 degree we get. So, therefore, the diagonals of a rhombus bisect each other. Okay, this is the proof. Now, example 3. Example 3, you can see here. ABC is an isosceles triangle. You know what is an isosceles triangle? Isosceles triangle, if two sides are equal, then such triangle is called isosceles triangle. Okay, isosceles triangle in which AB is equals to AC. AB equal to AC. AD bisects exterior angle PAC. You can see here in this diagram. ABC is an isosceles triangle which has AB equal to AC. Okay, and AD, you can see AD bisects exterior angle PAC. This is the angle PAC. This is the angle. Okay, and it is bisecting. AD is bisecting PAC, angle PAC. And CD is parallel. CD is parallel to AB. Show that DAC is equals to BCA. This alternate angles. Okay, we'll see. Now, and then we have to prove that ABCD is a parallelogram. ABCD is a parallelogram. Okay, now solution. Triangle in first one, triangle ABC is an isosceles triangle in which AB equal to AC. So angle ABC is equals to angle ACB. Yes or no? Angle ABC is equal to angle ACB. Both the angles are equal. Why? Since angles are opposite to equal sides. Equal sides we have, so therefore opposite angles are opposite to this, opposite to this. They are equal. Also, PAC is equals to ABC plus ACB. Okay, ACB, exterior angle of a triangle. Okay, for this, these two are the exterior angles. Okay, now PAC is equals to, both are equal, isn't it? Okay, so the previously just now we proved both are equal, so therefore 2 times ACB, call that as 1. Now AD bisects angle PAC. AD bisects angle PAC. Okay, now so angle PAC is equals to 2 times DAC. Okay, call that 2. Now since here PAC, here PAC is there, so if we equate, we'll get 2 times DAC is equals to 2 times ACB. 2 will get cancelled. Okay, this we got from 1 and 2. DAC is equals to ACB. Got. Okay, now let us see second part. DAC, angle DAC is equals to angle ACB. They are alternate angles. So BC parallel to AD, BE parallel to CD. Now both pairs of opposite sides of quadrilateral ABCD are parallel. So ABCD is a parallelogram. Okay. So next one is example 4 that I will explain in the next video. Okay. Thank you, children.